In this video, we're going to do a problem number 3 from the practice final, and that problem goes like this. Are students whose parents have a graduate degree, parental level of education equals master's degree, more likely to have an overall grade that's above average? Oh, two question marks here. So this has the keyword likely in it, so it's presumably a question about conditional probabilities, so a chi-square test. And indeed, if we look carefully in there, we're going to see that I have two variables. My first one is parental education, and my second one is overall grade. And even though overall grade looks like a numerical variable, actually here what I have is a grade that's above average. So above average and not above average, those are categories actually. So this looks like a chi-square test. So parents' education, I'm going to have a master's and no master's. These are my two categories. And for overall grade, and so those are my independent categories because they're before the word likely, and the two categories for overall grade will be above average and average or below, or not above average. So this indeed is a chi-square test. So I'm looking for a translation of my prompt into a claim about conditional probabilities. It's always helpful, I think, to start with the independent variable, because we know that that goes after the bar. So in this case, I'll have the probability given that my parent has a master's degree. Then that we're looking for the probability that I am above average. And the claim is that this is going to be larger than the probability of the students whose parents do not have a master's degree and their capacity to get also a grade that's above average. So this is what my claim would look like in terms of conditional probabilities. And once you find this, it's easy enough to get the null, which is simply replacing whatever is in there by an equal sign, and there you have your null. So this also requires that we actually look for the average. We don't know what the average is, so we have to look for that, but that should be easy enough. We'll turn now to the Excel for that. So again, this is, because it's a chi-square, we don't have to do any reordering of the data. I'm just after here my parental level of education. So I'm going to click on the first cell. I'm going to go all the way down. I click and maintain on the shift key, and then I click in the bottom cell to make a selection of this. I'm going to copy and use a paste special, because I like to get only the values. And then I'm going to do the same thing for the overall grade. I'm going to make a selection of the entire list, and I'm going to paste special only the values in here. Now there's one more step I need to do actually, is I need to figure out what is the average of all these numbers here. So I could do that anywhere, but I'm going to do this here. I'm going to do average. And then I'm going to say I want the average of all these numbers again. This is the way to compute the average, and it's 81. So I'm looking for grades that are above 81 and grades that are 81 or below. So I'm going to build my two-way table now. And we know that the independent variable is masters or no masters. And the other one here will be, let's call that a more than 81. And this one is going to be smaller or equal to 81, and I need my totals, and this is my basic layout for This I said this was above average here, and this is below average. Like this, I think I'm good to go. So now what I need to do is count. So I'm going to count. I'm going to use again the count ifs with an F. I don't quite see them in there. Count ifs here. And then I'm looking for things in this first column here that goes from A2 to A101. And in there, I'm looking for, and it has to be spelled exactly the same way. I'm looking for, there's not many people, I guess, with a master's degree, but it's spelled like this, master's degree. There you go. And then I'm looking for people now who have parents who have a master's and whose grades are 81, or rather above 81. So I'm going to go like this, above 81. And that should be, that should count all the, so there's only 4 in there apparently. Once I'm done with one, I can copy this. I'm going to get out of there using the little red mark here to make sure that I don't do anything I don't want to do. In this case, I'm looking for anything but a master's degree. So I'm just going to use my diamond operator here that says basically count anything except a master's degree in there. And I'm going to still look for people who have more than 81. So there's way more. And here I'm going to still copy. I'm looking again at people here who have a master's degree, but then I'm looking for people with smaller or equal to 81, which is the average. Not very many again, because there's few people who have a master's. And this one, it's no master's, so it's my little diamond here. And with this one, it's going to be smaller or equal to 81. And again, there's fewer people in there, but it doesn't look so good in terms of a big difference, because it looks pretty much the same. So I'm going to do the sum here for this, and I'm going to copy this one over here. I'm going to do the same thing the other way around for my marginal row total. So I can copy this one and paste it here. So if I do the sum here of the data that's inside, I should look at the marginal row totals. They should add up to 100. And same for my marginal column totals. And here everything looks fine, so I think that is my observed tables. My data in here, some of the entries have less than 5, but that's my observed table, so I don't really care about that right now. I'm going to care if the same holds for my expected table. That's going to be a different story, but here I don't need to care about that too much. So the next step, though, is to figure out if my claim holds in the sample. So my claim is that I'm more likely to have a grade that's above average if my parents have a master's degree than if they don't, but perhaps not sure if that looks good here. So this, the probability of A given M is the cell count where A meets M divided by the marginal total associated with M. This is 7. So there's my probability. And the other one, the probability of A given N is the cell count where A meets N. So this one divided by the marginal total corresponding to N, which in this case is this one. Oh, but it does hold, actually, just barely, but it does hold within my sample. So far so good. What I want to know now is if I can generalize this to the population. So in order to do that, I need a chi-square test. So I'm going to first copy this material here. I'm going to, as usual, do a paste special values only, because I'm going to delete the inside of my table and replace it with the expected cell counts. And those are always, you get to them always the same way. It's the marginal column total times the marginal row total divided by the grand total. It's going to, you never round them up, so it's going to be the same thing here. Marginal column total times marginal row total divided by grand total. And again for this one, equals marginal column total times marginal row total divided by grand total. Whoops, grand total here. And one last time, marginal column total times marginal row total divided by grand total. I think it looks good, but here we have a bit of an issue because we have two values here that are smaller than 5. So we can't keep going with the chi-square test. We have to do a Fisher exact test instead. So the first step of the Fisher exact test is to find the smallest marginal total. So in this case, it's pretty obvious. It's my number 7 here. And I have two choices here. I can work with this cell or this cell. And if we have a choice on a row like this, we said that we would always go for the left one. So this is my cell here. I'm going to use this one. Actually, we use the observed cell counts. So it's going to be E17. So I'm going to write it here, E17 config. And in there, I'm going to list all the options from 0 to 7. So it's going to load. So what I'm doing now is I wrote 0. Maybe I should start that again. I wrote 0, and then I hit my little fat corner here while holding the option key down, and this enables me to copy and increase as I go all the way up to my smallest marginal total here, which is 7. So the next step is to compute the probabilities of all those possible configurations. So in order to do that, I'm going to go and get the formula from the website. This is the section about the Fisher exact test. And here it's at step number 3. I have this formula here that I want. I'm going to copy this here and bring this back to my document here. So this goes in here, and I need to make some adjustments here to the numbers, but here my config is going to be, in my case, I18. This here is the first one in here after the config is the marginal column total. So in my case, it's E19. So I'm going to edit that here. This one will be the marginal row total, so it's going to be G17. And this is going to be the grand total, so it's going to be G19. So a bit of adjusting here, but then I get the probability of this cell here, this configuration 0. So if instead of a 4, I had a 0, I would get a different table, and that the probability of getting that table under the null, given the null is the case, would be this here. I'm just going to copy over using the option key again in my case, and then because I used the dollar signs in there, these cell references remain the same, and only the first one is changing. So this one has become I19, I20. And now what I need to do is look at my configuration. Here is my number 4. So it's this one. So I'm looking at all the probabilities that are smaller than this one. So it turns out this one actually is the largest probability. So in this case, I have to add everything. So I'm going to write p-value here, and I'm going to compute the p-value. So the p-value is equal to, you add everything. So I'm going to do sum of these 3 here, plus also the sum of these 3 here, because they're all smaller. I'm looking for anything that is smaller than the probability associated with my actual cell configuration. So then I want to add half of this number here. So I'm going to add half of that number. I'm just going to add parentheses just to be sure. And I'm going to try that out. And this is my p-value. So my p-value, again, is the sum of all the probabilities that are smaller than the probability associated with my actual configuration, which is number 4. In my case, it turns out that number 4 is the largest probability, so everything else is smaller. So I add everything else plus half of the probability associated with my cell. However, in this case, I get a p-value that is much larger than my 0.05 that I'm after, so I'm afraid that's the end of our problem number 3. So I cannot assume that my hypothesis holds in the population, and everything else after that is not applicable.